thermal, chemical, nuclear, solar, electrical, gravitational, kinetic, potential, mechanical, and so on, are all different forms of energy. However, why exactly are these forms of energy different from one another? And do they really exist? Before we even get to different forms of energy, we need to revisit what exactly energy is. Based off of the most common definition, energy is the capacity to do work. In case you were wondering, work is the physical quantity that we get whenever there is a push, pull, or any force that causes some motion, the key term being motion. So energy basically puts an upper limit to the amount of work that could be done by a body. A body cannot do more work than the total energy present within it, and as a body does work, its total energy will reduce by exactly the same amount as the total work done. Now that we know what exactly energy is, we can list out a few things that does or allows us to do work. For example, we could consider heat energy. We know this energy can allow for hot air balloons to move, hence it does work. It also cooks our food and makes us feel hot, which all happens due to the induced motion within the particles of the body. Another form of energy could be wind energy. Wind clearly pushes the turbines on windmills, which is definitely work. Similarly, we could consider sound energy, which moves our eardrums, giving us the sensation of hearing. When you think a bit deeper about each of these examples, we see that all of them are actually more similar than they appear. Heat energy is just the vibrational motion of tiny particles, such as atoms or molecules, which are present in the object. Similarly, wind energy is also the motion of the molecules of air. Sound energy is also just a traveling wave of compressed and relaxed air particles. So overall, all of these different energies stem from the fact that the particles that make up the objects are in motion. We call this collective energy due to the presence of motion as kinetic energy. This kinetic energy does not necessarily have to be bound only to individual particles of a body, but it could be present due to the motion of the body as a whole. For example, a rotating body such as a top could collide with a small obstacle and fling it away. This implies that the rotating body has a form of energy that we call rotational energy, which is also just a form of kinetic energy. Similarly, a car traveling fast also has a lot of energy known as translational energy, which again is nothing but kinetic energy. However, a car would also possess some rotational kinetic energy due to the wheels and other parts of the engine. So most forms of energy can be boiled down to kinetic energy, but certain objects can do work without having any specific inherent motion. For example, a compressed spring, when released, can easily push an object. The same would go with a stretched rubber band, and so on. We call all of these kinds of energy as potential energy. They have the potential to invoke kinetic energy. Another example of such a potential energy is a ball placed at a height. It has what we call gravitational potential energy, as it has the potential to create kinetic energy as it falls towards the ground. A similar analogy works for charges placed close to one another, which we call electric potential energy. Just as kinetic energy in the molecular scales was termed as heat energy, potential energy at similar atomic scales is responsible for many forms of energy. Chemical energy is the potential energy due to the presence of electrons in atoms, which are trying to bind with other atoms to reach various forms of stable configurations due to the quantum effects of electric potential energy itself. If we go a bit smaller, we see nuclear energy is simply the potential energy present among the protons and neutrons in the nucleus that leaks out due to the weak nuclear interaction causing radioactive decay. Even further, we see that the rest mass energy from the famous E is equal to mc squared is also nothing but potential energy due to the interaction of fundamental particles with the Higgs and gluon fields. However, this deserves a video series for itself. Furthermore, if we consider the potential energy due to the configuration of the objects, such as in the case of rubber bands and springs, we can see that in the atomic level, these energies are also due to the electromagnetic interactions of their constituent particles, implying that they are just macroscopic versions of electric potential energy. The relationship between true forms of potential energy and the fundamental forces with the Standard Model will also be revisited soon. So, no matter what kind of energy we're talking about, it really is just one of two types: kinetic energy, which is the energy due to the motion of particles, or potential energy, which is the energy due to a particle's position with respect to other particles or its configuration or composition. A few kinds of energy is sometimes slightly harder to categorize into one or the other. For example, sound energy is mostly kinetic energy, but it does carry some potential energy in the compression of the waves. Similarly, light energy is definitely energy, as it can push objects such as the tails of comets, but it is much harder to classify as kinetic or potential. This is because light is simply an oscillating electric and magnetic field. These electric and magnetic fields have potential energy, which moves the electrically charged particles in our bodies, such as electrons, which then in turn create their own fields that interact with the original fields, providing a force on the object which induces the motion doing work. This force, however, is induced only because the electromagnetic waves of light are moving in space. Therefore, light energy can be considered as a bit of both kinds of energy. In the end, energy is just a number which determines how much motion can be induced by an object on another object. It's just a mathematical tool that allows scientists to make predictions about the universe, and really isn't a physical entity of various kinds. All the different types of energy that we hear about are actually just kinetic energy, or the potential to create kinetic energy, which means that there really is only one type of energy. Thank you for being energetic enough to watch this entire video. Although topics like this have various videos on YouTube already, a different perspective always helps in refining one's understanding of the topics. Various concepts touched upon in this video, such as mass being nothing but energy, and how light is a form of energy that can do work, or maybe how fundamental particles define potential energy, will all be covered soon in various videos. So be sure to stay tuned to PhysiFacts by subscribing on YouTube and following us on Instagram for updates and crisp facts. Until next time, stay safe and stay curious.